With our basic laser blast in place, in this video, we'll create our alternative firing laser beam. In the link in the description, you'll find the link to freely download the assets and scripts or macro we created in this video. Feel free to download them and follow along, dissect the macro, or to simply use the completed effect in your game or project. Let's start by first adding our laser beam sprite into our scene, and then scaling it to match the size it will be if fired from our ship. Let's also place its sorting order layer to 19, which is the same sorting layer as our basic laser blast. Next, we'll add a capsule collider component and set the collider to its trigger. We can also adjust the size of the collider to better match the size of our laser beam sprite. Then set the game object tag to laser. Like our previous laser, we'll add a rigid body physics component and uncheck the use gravity and is kinematic. We'll then set the constraints for our rigid body component to freeze our X, Y, and Z axis. With our basic setup complete, let's now add a flow machine component and create and save a macro, which we'll call Astor Galaxy Laser Beam Macro. Before we begin creating our graph, let's first go over the logic we want to implement. Unlike our laser blast, we want our laser beam to appear as a constant stream of energy being shot from our ship. And since it's not a projectile, we only want it to last a brief period of time before it dissipates. To do this, we'll create 3 object graph variables. We'll call our first variable laser object. The next variable will be a float, which we'll call lifetime. And the last will be a vector 3, which we'll call laser size. We'll begin by using our start state to set our laser object variable and our laser size variable. Like our laser blast, for our laser object variable, we'll simply set that to self. We'll next need to use a get component node, which will use the output of our set laser object node to get our transform component. We can then use a transform get scale node as the input of our set laser size node. With our laser size variable set, lastly, we want to use a transform set local scale node, and we're going to use our laser object as our input object, and we want to set the scale axis of X, Y, and Z to 0. Next, we'll duplicate our start state and set it as a coroutine and set it to trigger a wait for seconds node. For testing purposes, let's put our wait for second duration to 1.5. From there, we want our wait for seconds node to then trigger a do scale node. We want to use our laser object variable. For the target object, we want our node to scale. For our ending size, we want to use our laser size variable. And for now, let's place our duration at 0.5. Before we continue, let's test what we've created so far. We can see at the start of our graph, our laser is set to 0, and after our wait duration is finished, that our laser is then set to its original scale, which makes it appear as our laser is being fired from our ship. With everything working correctly, we can now reduce our wait time as well as our dose scale duration. However, since our blast is fairly powerful, from a player and gameplay perspective, we don't want to remove our wait time entirely. This way, we can add a risk reward element for using this attack. Since we're only allowing the player to use one attack at a time, using this laser beam attack will leave them momentarily vulnerable until the beam is fully fired. However, we'll also need to add an effect so that the player is fully aware that there's a brief wait time before this attack begins. For this, we'll need to do 2 things. We first want to create a new empty game object in our scene, and then copy the transform component from our laser beam sprite and paste the values into the transform of our new empty game object. This will ensure that the pivot point for our game object matches the pivot point of our laser. And we'll also need to set all the scale values of our new game object to 1. And let's rename our new object to laser beam. Let's now place our laser sprite game object as a child of our new laser beam game object. And let's also copy our variable in our flow machine component from our child sprite game object and paste them onto our laser beam parent game object. With our variable and flow machine component pasted, Let's now remove those components from our sprite game object. Let's now add another laser beam sprite into our scene. And we'll use this sprite to act as a visual representation that our beam is charging and about to fire. So we'll want to place and size it at the base point of our laser beam. And we also need to be sure that we place it as a child of our laser beam game object and below our laser beam sprite game object. And we'll also need to be sure that we place its layer sorting order to 19. Let's next go back into our graph. And we want to start by making two object graph variables, one for our charging sprite and the other will be for our new sprite game object. Before we start creating our new functionality, we first need to modify the set laser object variable nodes. Since our laser sprite is now a child of our laser beam parent object, we can't simply use self to set the variable. Instead, we want to use a transform getChild node, and for the target transform, we'll simply use self. We want to then use that transform output on a GameObject getGameObject node and place the output value in our set laser object variable node. If we quickly press play and go to our variables, we can see that our laser object is set to be our laser beam sprite, which is the first child of our laser beam parent game object. After our transform set scale node, we want to create a node to set the variable of our laser charge object. We'll use our getChild transform and getGameObject nodes and place them in the input of our set laser charge variable node. And we'll also need to change the index of our getChild transform node to 1. And let's also duplicate our getComponent and getLocalScale nodes and use them to set the value of our laser charge size variable. Lastly, let's use our setLocalScale node to set the size of our laser charge object to 0. Let's next set our wait duration to 1 second. Let's now copy these nodes and group, and we'll use this new group to scale our logo charge object. We'll change the delay from our laser charge wait time from 1 to 0.1, and we'll make our scale duration the same value that we use for our laser object wait delay. Let's next place a custom event after our laser object dose scale, and we'll use this custom event to trigger our lifetime countdown. For our lifetime, we'll simply use a GameObject destroy node like we used in our laser blast. With that complete, for the moment, let's set our lifetime to 3 and then go in our inspector to test out our functionality. We can see at the beginning our laser charge object scaled to its full size right as our laser beam was being shot. Additionally, if we look in our variables, we can see that all of our sizes and objects are being stored, and within 3 seconds, the laser beam game object destroys itself. With our laser beam in charge now working correctly, let's add one more node before adding our firing functionality to our spaceship flow machine. So let's create a scene boolean variable which we'll call isAltFire. And before our object is destroyed, we want to set that to false. So let's duplicate our custom event node and use it to create a wait for seconds node. For our delay, we'll subtract our lifetime by 0.05 seconds. This way we can ensure that our graph has enough time to set our variable before it destroys itself. From our wait node, we'll then go to our isAlternateFire set variable node and we'll set that boolean to false. With our graph complete, let's now create a prefab of our laser beam. And for our prefab, let's zero out our position. And we can now remove the laser beam from our scene. Let's now go into our spaceship flow graph. To begin, in our keyboard input laser fire group, after our keyboard input event node, we want to place a branch node to check and see if our isAlternateFire true or false. We want the player to be able to shoot their laser blast only if our isAlternateFire boolean is false. Next, let's create two scene variables, and we'll make the first a GameObject variable, which will store our laser beam prefab. The second will be an integer, which will represent the amount of time the player can use their alternate fire method. And let's place our laser beam prefab as the value of our scene graph laser beam prefab variable. Next, let's select and duplicate our keyboard input fire laser nodes and group. Let's first change our input key. After our is alternate firing branch check, we want to create another branch, which will check and see if our alternate fire charging variable is greater than or equal to 1. After our second branch node, and before we go to our for each loop node, we want to create 2 set variable nodes. And we're going to use these nodes to set our is alternate firing boolean variable to true. We'll use the second one to subtract 1 from our alternate fire charges variable. Next, we need to change our laser blast prefab into our laser beam prefab. And after our game object instantiate node, we want to create a transform set parent node. For our input transform, we can use the output of our game object instantiate node. And for our parent transform, we can use the transform of the current index item in our for each loop node. With that complete, let's test out our functionality. We can see that our laser blast not only fires from our ship, but also moves with our ship as well. Additionally, our alternate firing charges are taken down by 1 each time we fire our laser. And we're also prevented from firing our regular blast until after our laser beam is complete. And if we try to initiate our laser beam again, we can see, since we don't have any charges, we're prevented from firing our laser blast. With our spaceship flying controls and our weapons firing mode created and complete, we'll create our player HUD and begin work on our game manager, which will be responsible for our game's points, enemies, player spawn, as well as controlling the different states of our game.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, and free game asset giveaways.